Right, good afternoon, my beloved Form 4s. Right, so today I want to answer the question which I gave you yesterday. That was the question on graphs, quadratic graphs, quadratic graphs. Right, so this question was borrowed from speed time graphs. Speed time graphs, speed time graphs, or velocity time graphs. So a question was saying a boy playing on a swing as his velocity v minutes per second at time t seconds given by v is equivalent to t squared minus 40 plus 4, right? The following is an incomplete table of values for v. So our incomplete table was saying v is equivalent to t squared minus 4t plus 4. So this one was our graph, or our function, right? Our function which we were going to work with, right? So the table of values was given. The table of values was given with incomplete values, right? So you were asked to find the value of p, the value of p. So you were asked to find the value of p. So to find the value of p, you're supposed to substitute the values of t in the function given. Because this p is a value which is representing velocity, So p is equivalent to, right? So p was corresponding to 0,5. So 0,5 then squared minus 4 by 0,5 plus 4, right? Then we say 0,5 squared by 0,5 multiplied by 0,5, which is equivalent to 25, then 1, 2. So here we get 0,25 minus 4 times here we get 0,5 multiplied by 4, we get 20, right, which is a 2 plus 4, right? So p was 4,25 minus 2,00, which is equivalent to 2,25. So the value of p was 2,25, right? So now part B, using a scale of 2 centimeters to represent 0,5 seconds on the horizontal axis and 2 centimeters to represent v on the vertical axis. Draw the graph of v is equivalent to that one, right? And we were given a range, right, of t. The values of t were supposed to be from 0 up to 4. So our grid supposed to be this one, right? So this one is our time. This one was our time in seconds. Then here our v meters per second, which is our velocity, right? So here this is our 0, 1, 2, 3, 4, right? So that this is our scale, right, which we were told to use. So that's 1, 2, 3, 4, right? 2 centimeters represent 1 meter per second. So here that's 1, 2, 3, 4, maybe 5. Choosing to present here, this is wrong. 0.5, then 1, 1.5, then 2, 2. Right, let me reduce my scale here. My scale, right, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. Right, so that's my grid here, that's my grid there. Now I start to plot the graph. So from point number 1, it's saying when t is equivalent to 0, v is equivalent to 4. When t is equivalent to 0, then v is equivalent to 4. Then I place my plotting there, right? Then when t is 0.5, when t is 0.5, when t is 0.5, right, let me draw the table of values here so that you can see. So this is our t, this is our v, right? 0 is corresponding to 4, 0.5 is corresponding to 2.25, right? 1, 1.5 to 0.25, 2, 0, 3, 1, then 4. Right, so that's our table of values there, right? When t is 0.5, when t is 0.5, our v is 2.25, right? So 2.25, maybe it's somewhere here, right? This is my sketch diagram, but if you use a scaled diagram with a grid, with a graph paper, right, it will get you at the correct point, right? Then 1, 1, right? Then 1.5, and 0.25, maybe somewhere here, right? 2 and 0, that's here, right? 3 and 1, right? Somewhere here. 4 and 4, 4. Right. Then you join the plottings using a sharp pencil, right? You draw your curve. Right. So here is my graph. This graph is of the equation v is equivalent to t squared minus 4t plus 4, right? So this is my graph. That is my graph there. Now use your graph to estimate the time when the velocity was 1.5 meters. 1.5 meters. So you come here, right? So when v is 1.5, maybe 1.5 is here in just a second, right? I now find out t1 and upper. So t maybe was approximately equal to maybe 0.8 seconds. That's my answer, right? The acceleration when t is equivalent to 3, when t was 3 here, what was the acceleration? The acceleration now, acceleration now, acceleration acceleration equivalent to change in v over change in t, right? So I now draw a tangent. To find this acceleration, because this acceleration is the same as the gradient. Right? So this is my plotting. So when t, my first point t3, then my velocity is 1, right? That's my first point. Right, then I now take another point from any point, maybe here, right? Then I find out right, when t is 4, right, my v maybe was 2.4, right, 2.4, right? So now I say 1 minus 2, 4, and I get negative 1, 4 over 3 minus 4, which is negative 1. So my acceleration was 1,4 meters per second. That was my acceleration. Using the same axis, draw the graph of v is equivalent to 10. So I'm now asked to draw the graph of t is equivalent to 10t. V is equivalent to 10t, right? So V is equivalent to 10t. So this one is a straight line graph. This one is a straight line graph. So to draw this one, I have to draft my table of values. T and V. Right? Then I say when V is equivalent to 0, when t is equivalent to 0, what will be when t is equivalent to 0? V will be 0, right? When V is equivalent to 0, what will be? When V is equivalent to 0, then t V becomes 0. When t is equivalent to 1, right, our V becomes 10, right, like this one. Now I plot the points. So from 0, 0 up to 1 and 10, 1 and 10, 1 and 10, maybe it's Kusoro, right? Then I place my 10 there, right, 1 and 10. Right, then I draw my straight line using a ruler, right? That's my straight line. Which is the graph of V equivalent to 10t. Is equivalent to the graph of V is equivalent to 10t, right? Use your graph to find the time when the boy and the object had the same speed, right? So here is at the point when the boy and the object had the same speed. So I am asking to find the time. So the time maybe was, then I estimate here is 0,4 seconds. Maybe at this time, right? The boy and the object had the same speed. Given that the boy and the object collided at the same time, they had the same speed. Use your graph to find the distance the object had traveled. So this is from here up to here. That's the distance.